Let's take a look at square roots and radicals. Radicals is basically a square root, but it's more of a general term. A square root very specifically talks about a little 2 that might be down inside of what we call the index. This index says what squared is 49. If you look over here, the index is a 3. So this is what cubed is 27. What to the third power is 27. So a radical is more of the term we would use if we might have different numbers tucked down inside the index. A square root is very specifically a 2. So that's the difference between the two. Whenever we're looking for what is the square root of something, that means what times itself. So if you look at 49, you want to think what times itself is 49. That little 2 is obviously invisible. It's usually invisible. It doesn't usually show up because it's an assumed 2. But we do know that it's going to be a positive 7. So 7 times 7 is 49. So you just simply say 7, and that's all. This one here, I'm going to sneak these little 2's out of there. This one here has a negative on the outside. This actually means -1 times the square root of 36. That's what that negative means. We don't put 1's there ever because a 1 is assumed. We just know that that's what it means. So first, order of operations says let's do parentheses. We don't have any. Exponents. Well, radicals or square roots are in the exponent family. So we're going to solve the square root of 36, which is 6. And then we're going to say times -1 because that's multiplication. So we're going to then get a -6. So if we were to try to solve this back the other way, we would think, okay, what times itself is 36 and then times -1. So there you go. A fraction. Don't let this scare you. Let me show you it in 2 ways. We can simplify right off the bat and just say what's the square root of 81 over 25, meaning what's the square root of 81? What's the square root of 25? Leave them in the fraction and you're done. You can also look at this as the square root of 81 divided by the square root of 25, and then you can solve. So in this case, we're just going to say 9 over 5, and that's the same thing here. We would just say 9 over 5. So again, you get the same answer, but there's 2 ways to write that. Look up here with these 3's in here. The index is a 3, and that indicates what times itself 3 times gives me 27. Another way to write this would be x cubed equals 27. So we're trying to figure out what cubed gives me 27. So let's say we just don't know. It's not coming to us. So here's a really cool little way we can do it. Remember factor trees? We're just going to find a grouping of 3. So when I think of 27, I'm going to think 3 times 9 gives me 27. And then a 9 is a 3 and a 3. Well, whenever we have an index of 3, that means I need to have 3 identical integers that multiply together to make that number. And it just so happens 1, 2, 3, I have 3 3's. So the answer to this one is 3. Pretty easy, right? This one here has a negative. So the only thing we're going to think of differently is what times itself 3 times gives me a -27. Well, if it was a 2 or a 4 or something that's an even number, that's not going to work. But with odd numbers, it does work. Because what is -3 times -3 times -3? -27. So the final answer for this one would just be a -3. Think about it. Negative times a negative is a positive. Positive times a negative is back to a negative. So that's why that will work. So a -3 cubed is -27. And last but not least, look at all these symbols. So what is the negative cubed root of a -343? Well, again, oh my goodness, 343. I have no idea. What goes into that? Nothing that's obvious to me. I'll just give you a hint. It's a 7. So 7 times 7 is 49. and 49 times 7 is 343. You can check it on a calculator if you want to, but for sake of a shorter video, let's just get right on to this. So here's where it gets a little tricky. So I know that I'm just going to solve this part first. So I'm going to almost put parentheses in there just for myself. I want to go ahead and say the cubed root of negative 343 is negative 7. Well, this negative hasn't been used yet, so notice that I brought it over, and then I put the answer as negative 7. When you have a negative outside, this is the same thing as saying negative 1 times negative 7, which is just a positive 7. So all of this ended up just being 7. Oh my goodness. Yes, sometimes math is definitely a head scratcher. Why do you care? When will you need to care about this? This one, probably just for a math class. I don't know that you're going to see this anywhere else. Shh. Don't tell your teacher I said that. Or you can. It's okay. But just own it. Just know. You're going to need it to pass the test. But this hopefully just made it a little bit more clear. Nicely done.